So this is a mock paper 4, set 1. Figure 5.1 shows the particles or molecules in a sample of a liquid. Use an idea about the particles why liquid expand more than solid for the same temperature rise. So what is the reason why the expansion of a liquid is greater than the expansion of the solid? So solid, the particles are tightly packed together and they have a strong force of attraction as compared to that of a liquid. So when we supply the same amount of heat energy, the particles can move large space as they already have a space between them. So they can move a large space. So the mark distribution, first thing, as we increase the temperature, the particles will move faster and liquid force is weaker, so the particles can move away. Like how we write the answer, when we supply the heat energy, the particles will vibrate, move faster. Because of the weak force, the particles can move away easily. But in solid, the particles are tightly packed together. As a solid, the particles are tightly packed together. So, and they have a strong force, so they will vibrate and move, but the spacing between the particles in a solid, there will be a small increase in space. The boiling point of a water is 100. State the boiling point of a water in Kelvin scale. So if we want to convert into a Kelvin scale, so what we simply do, we will add 273. So temperature in Kelvin is equals to temperature in degree centigrade plus 270. So 100 plus 273, 373 Kelvin. Then the temperature remain constant as a water turn from a liquid to a gas. Explain in terms of the particle why energy must be provided. So particle, because what we have to do whenever we want to change the state, the energy is provided to break the intermolecular force. So we break the force between the particles or intermolecular force so the particles can move away from each other. No, but you have to, why we must supply? So not particle need absorb energy. What we have to do, we have to supply energy to break the force of attraction between the particles. This will not score a mark here when you say particle need to absorb energy when change state. The question is why particles need energy to change the state, because the energy is needed to break the bonds. So if we want to break the bonds, we have to supply energy. Yeah, if you write break the bond between the particle, that is a right term. Energy needed, if you use the term energy needed to separate the particles, energy needed to overcome the intermolecular forces, or energy needed to break the bonds, all will score the marks. Yeah, this answer is more related to chemistry rather than physics, but because the thermal physics is a mix of chemistry as well, in which you study a Brownian motion and the changing state, heating and the cooling curve. The next is an electric heater is used to heat a sample of a metal as shown in figure 5.2. There is no thermal energy transfer from a metal to the surrounding. The metal has a mass of a 200 gram. So we have the mass of a metal 200 gram. So SI unit is kilogram. So we divide by 1000.2 kg. Initially at 15. It's for 2 minutes. Time should always be in seconds. So means 2 multiplied by 60. So it will be 120 seconds. The maximum temperature is 40. So that's the final temperature. And this is the initial temperature. Calculate the specific heat capacity. So if I need the specific heat capacity, it's the energy divided by mass into temperature change. Temperature change in some books, they represent by delta theta. That is also fine. You can use delta T or delta theta. Both are correct. If you use this symbol, that is fine. If you use delta T, that's also correct. But energy supplied by using a electrical heater. So energy is a product of a power and time. So I can say energy is equals to power multiplied by time, specific heat times the temperature change. So power of the heater is 20. It is used for 2 minutes or 120 seconds. The specific heat capacity, the mass is zero point 0.2 and the temperature change 40 minus 15, which is 25. So what is the value for C? The specific heat capacity? If you don't convert the unit, let's say you don't convert the unit of the mass. So if you don't convert the unit of the mass, the specific heat capacity will be joule per gram degree centigrade. But because I converted the mass into kilogram, so the specific heat capacity should be joule per kilogram degree centigrade. What's the final answer? 2400 divided by 25 into zero point 0.2. So 2400 divided by zero point 0.2, and that is divided by 25. So it is this is not the right answer. The correct answer is 480 joules per kilogram degree centigrade. So when you simplify this, you will get 480 joules per kilogram degree centigrade. But here the unit is joule per gram. So if the unit is joule per gram, I don't have to convert the unit. Then in that case, I don't have to convert this mass into kilogram. I will use just a gram and I'll get a different answer. It will be about, because it was 4,480 joules per kilogram degree centigrade. In gram, it will be about 0.48 because divided by 1000. No need to convert the mass here. Why we don't have to convert a mass? Because the unit is already given in joule per gram. So I don't have to convert the mass. I will use the same mass, 200. In question 6, the virtual reality headset in a figure 6.1 contain a display and a lens as shown in figure 6.2. An eye is there, a lens is there, and a display, not to scale. The display is the object of for the lens, like this is an object for the lens. The lens act as a magnifying glass. So when the lens is acting as a magnifying glass, it means the object is placed between the focus and the lens. So means the object is between the focus and the lens. The lens acts as a magnifying glass and form a virtual image on the display. Describe where the display must be positioned relative to the focal length of a lens to act as a, so it should be placed within the focal length. Means the distance shorter than the focal length or within the focal length or small. It should be placed at a distance less than the focal length. You can also say that within the focal length, distance less than the focal length. How a virtual image is formed. Explanation of a virtual image means that the rays will not meet after passing through a lens. When the rays do not meet after or do not converge when it passes through a lens, then it will appear to be a virtual image. Like what actually happened, say this is a focal length, sorry, this is a principal axis, I mean, and here is a focal length f is there. So light passing through a lens will go through the focus, one through the center, one through the center will pass straight. So these two light rays will never meet. So as the light rays will not meet, what kind of image it will form? It will form a virtual image. For a virtual image, yes, you can say the image which can not be seen on screen or image will not come on the screen, that is also fine, or will not appear on the screen. This is also, you can say that as well. It's of only one mark. So image which cannot be seen on the screen. How virtual images form? So virtual images form because the the light rays passing through the lens do not meet or converge. Or the image cannot be seen on screen. Is it okay if we say that the image cannot be projected on the screen? Yes, that's the same point what I mentioned. You can say that as well, that the image is not projected on the screen. This is fine. Or image is not taken. So how virtual image is formed? So virtual image is formed, but the explanation is how it is formed. So appropriate answer is in terms of the ray. But they do accept that the virtual image is formed because the rays does not meet on the screen or image does not form on the screen. That's why it's forming a virtual image. Now an arrow on the display is 3.4 centimeter from the lens. The virtual image of an arrow is 22 centimeter from a lens. Figure 6.3 of an object and the lens is and the virtual image is I. Then on a figure, draw a ray diagram to show the formation of a virtual image. How virtual image is formed? Look, if you remember, first thing, first I'm drawing it here just to give an idea. Then I will complete that figure. Yeah, but you have to draw from tip of the object. Yeah, that's one thing. And then the second ray is also there. Good. Because how the virtual image is formed, if we have a lens and we place an object in front of the lens, so first a parallel light ray, and that will pass through focus, but the focus is, we don't know the focus. But how we can work out the focus if we know the position of image? Because when we draw a line, a continuous line from tip of the image to the point where it meets the lens, this line will give us the idea for the focus. One through the center will pass straight and we produce them backward. That's how the image will be formed. Because this is an imaginary image. Imaginary image is formed by when the rays of the light does not meet by themselves. As you can see, first a parallel light ray will pass through the focus and one through the center will pass straight. We produce them backward. So we get the position of the image. Then determine the focal length. What is the focal length? Because this parallel light ray will pass through focus. So this is a focal length. And how we know, according to a question, they mention that 1 centimeter represent 2. So how many boxes are there? 1, 2, 3, 4, 5 boxes. So 5 boxes equals to 2 centimeter. And then the scale like 2 centimeters there. So this is 1, 2, 3, 4, 5. This is 2 centimeter. 1, 2, 3, 4, and about 5. So this is 4 centimeter. But according to the question, according to the scale, it is already given. So we just have to measure because actual 1 centimeter scale is 1 centimeter represent 2. So this length of 1 centimeter, it's when you use a ruler on your paper, this is actually 1 centimeter. And what 1 centimeter is representing? The 1 centimeter is actually representing 2. So when you measure this, like 5 boxes are there. So here 10 boxes. So 10 boxes, 5 boxes equals to 2 centimeter. So 10 boxes equals to 4 centimeter. So the focal length will be 4 centimeter. Is it clear this one? How we worked out the focal length?
Yes, sir.
Okay. How we can work out the focal length? As already they mentioned, that this 1 centimeter, because you will have a hard copy in exam, in the question they already mentioned, this is actually 1 centimeter, okay? But this actual 1 centimeter is representing 2 centimeter, the right distance. So when you complete the figure, first a parallel light ray, but we don't know the focus, so we did not complete. One through the center will pass straight. So from tip of the object, we draw another tip of the image, we draw another ray, and we continue that. So this will give us the focal length, F. Because the parallel light ray always passes through the focus. Now, In the figure, 1 centimeter is representing 2. So this 5 boxes is 2 centimeter. Like example, 1, 2, 3, 4, 5. So this is 2. 1, 2, 3, 4, 5. So somewhat here, like because you will get a range answer here, but usually the accurate answer, this is 2 plus 2, the total focal length is 4 centimeter. A water wave in a ripple tank diffract as it passes through a gap in a barrier. On a figure state one way with the student drawing of a crest is wrong. As what is a mistake here? If you see the wavelength here and the wavelength here appear to be different. So the pattern is correct from the student, but the wavelength which he drew before and the wavelength which he drew after, it shows that the student has changes the wavelength. So student, the mistake here, no, not less wavefront. That is not, no. Not less wavefront. That is not the way you compare. It depends on how many students want to draw. But the main thing is the wavelength appear to be too large. So less wavefronts is not the right answer. No, it will not be curved. The pattern is correct because if you compare the wavelength and the gap size, so if you compare the wavelength, like this is a wavelength, and you compare the gap size, gap is larger. So if the gap is larger, then the wavelength, yeah, this is right. This is correct. This is right way of drawing because that shows a small diffraction and the gap is larger than the wavelength. But the mistake which student did, that student should draw the second wavefront with the same wavelength as were, like if this was say 2 centimeters, so this should also be 2 centimeter. But a student has drawn a longer one. So the mistake here in the student diagram is the wavelength not correct. Wavelength of a diffracted is longer than the wavelength of the incident one. The gap in the barrier is now made a smaller. Now this is a smaller gap. When the gap is smaller or wavelength approximately equals to gap size, so we have a maximum diffraction. So using a compass, draw this and keep one thing in mind, that if this is 2 centimeter, then the spacing between, yes, spacing between them should also be 2 centimeter. Okay. So be sure that you draw same space. If you draw a different space, it means you have changed the wavelength. Like if the incident was like this and I drew the diffracted one with a longer wavelength, then you will lose the mark. This one is for minimum diffraction. When minimum diffraction, no, this is not the right. This is to represent a minimum diffraction. Maximum diffraction, it must be a curve. So how you score 2 marks? 1 mark is for representing. How you score the 2 marks? 1 mark is for, yeah, freehand is acceptable, but in exam try to use a compass for the circular wavefront. So 1 mark is for the pattern and 1 mark is for the wavelength. It's not about the number, like here if 5 are given and here I do 4, that is not making a difference. That is not the idea that the number is different. Is it fine? You can use your mic, Ayan, to ask question if you have.
Sir, is it fine to make one wavefront?
No, not one wavefront, because the one is does not make a comparison about the wavelength. Like if you draw, you are saying if you draw only one wavefront, that is not correct. Why? So you will only score 1 mark here. Why? You will score the mark for the pattern, but not the wavelength. So it should have a same wavelength. That's why at least 2 should be there or more than 2. So we should always, all the cases, we should draw the same wavelength. The wavelength should not change until unless the gap, until unless the medium changes. How the gap size and the wavelength are related? If we have a gap size or a wavelength, I can write first. If we have a wavelength is greater than or equal to the gap size, then we will have a maximum diffraction, means curve will be there. But if we have a wavelength which is less than the gap size, gap is larger, we'll have a minimum diffraction. So how we represent? By straight lines, and only the edges will be curved. That's how the gap size and the wavelength are related to each other. So longer wavelength diffract more than the shorter wavelengths. In one part of a ripple tank, the water has a speed of 6 centimeters and the wavelength 2. The wave then passes into a shallow. The speed of a wave in a shallow is 4. Calculate the frequency of the wave. First, define the term wavelength. Distance from one point to another. No, that's not the complete or a right definition.
One crest to another.
It's a
Distance from one crest to another.
distance between the two successive crests or two successive troughs. Because if I say distance from one point to another, that is not the complete answer. Yes, Abdurrahman.
Sir, can we say distance from one refraction to one complete refraction to compression? Like distance between one successive compression and refraction?
If you, like length of one complete compression and rarefaction, that is one wavelength. Or distance between one center of one compression to a center of another compression, that's also wavelength. But here we should use the term length of one complete cycle. But you use the term standard definition. As you can see, what kind of wave is shown here? It's a water wave. So as we have a water wave, what are the water waves? Water waves are transverse wave. So when I define the term wavelength here, I should define in reference to the transverse wave. So for a transverse wave, the distance between the two successive crests or the two successive troughs is known as the wavelength. So I should use the term crest and a trough for a transverse. If let's say the question was about sound and they asked define the term wavelength, so I will say it's a distance between the two successive compressions or the two successive rarefactions. So it's important to answer the question related to the question. Like example, if it's about wavelength, wavelength can be for a longitudinal wave as well as for a transverse wave. So because here we have a transverse wave, so I use a compression and the rarefaction. Calculate the frequency. So how we can work out the frequency? We have the speed and we have the wavelength. So we can use the formula, the wave equation, V is equals to F lambda. So if I need the frequency, it's a ratio between speed and the wavelength. So speed is 6 and the wavelength is 2. So 6 divided by 2, I'll get 3 hertz as a frequency. And frequency never changes. The definition of a wavelength here is a distance between the two successive crests. So from one crest to another, we'll get so frequency, which is a ratio between the speed and the wavelength. So 6 divided by 2. That is giving 3 hertz or second inverse. Calculate the wavelength of a wave in a shallow. So because the frequency never changes, even in a deep or a shallow, if we worked out the frequency to be 3 hertz, so we'll have a frequency 3 hertz here. So V is equals to F lambda. The speed in a shallow is how much? The speed in a shallow is 4. So we put 4. The frequency is 3 and the wavelength is unknown. 4 divided by 3. So 4 divided by 3, what we'll get? We'll get 1.33 centimeter. And what will happen if the speed decreases, the wavelength will also decrease, but the frequency will remain unchanged. If you write here that the distance between one compression to another, that is wrong according to the question. Why? Because this is about the water wave. So you are supposed to explain the wavelength in terms of the water waves. That is, I'm saying, if they ask the question was there related to sound and they ask wavelength, then you should use the term distance between the two successive compressions or rarefactions. In question 8, a filament lamp is arranged above a shiny metal surface. So a student read in a textbook that the light emitting diode is more efficient than a filament lamp. State what is meant by the term efficiency. Efficiency is it's a how much useful energy is converted compared to the input, or it is a proportion, or it is a ratio between the useful energy and the input energy, or useful power and the input power. So when we take efficiency does not have any unit, it's represented in percentage. So the distance is a ratio between the useful energy and the total. Yes, you can write a formula as well. Efficiency is useful divided by input into 100. That's fine. Suggest why the efficiency of the filament lamp is very low. Because what happened in case of a filament lamp?
Thermal heat energy
Yeah.
is generated.
Because the filament lamp, what it produced lot of heat energy. So filament lamp is producing lot of heat energy. That is why we don't say that, like that is why it is having a low efficiency. Like it is converting most of the energy or losing most of the energy in the form of heat. If you write a formula, we'll score a mark in the definition. Yes, you will score a mark when you write a formula in place of efficiency. Like let's say you wrote what is meant by efficiency and you wrote that efficiency is the useful energy divided by the input energy times 100. You will score the mark. It is applicable. They do accept, but I advise try to learn the definition. They do accept this, but try to learn the definitions. Instead of input, if you say wasted, no, that will be wrong. If you say a wasted energy. A student consider replacing a filament lamp shown in figure 8.1 with a light emitting diode of the same brightness. The data about the filament and the suitable LED is shown. The LED light emitting diode emits the same amount of visible light as a filament. Use this information and the data in the table determine the efficiency of LED. If I want to determine the efficiency of LED, what is the efficiency? Efficiency is the useful energy divided by the input energy times 100. We want to calculate the efficiency of the light emitting diode, which that is what we have to calculate. What is the input power? How much input power is there? That is a 15 watt. And how much is a useful energy? Because they mention the filament lamp and LED give us the same amount of a light. So means the useful energy of the filament is same as the useful energy of LED. What is the useful energy of a filament? If this is the input power, 6.2 is efficient. So how much is a useful? Like if I work out the useful energy of the, so means it will be 6.2% of 120. The total input, 6.2% is efficient, like 6.2% of 120 is a useful energy. How I'll work out 6.2%? So 6.2 divided by 100 multiplied by 120. So we got 7.44. So 7.44 is the amount of, it's a power which is given by the both LED and the filament lamp. But the input of LED is not 120, the input of LED is 15. So it will be 15 into 100. So 7.44 divided by 15 into 100. So it looked like 7.5, about 50%. Not exactly about 50%, it will be efficient. Is it clear, this one? How we worked out the
Yeah.
Yes, sir.
efficiency? Yes? Should I repeat?
Yes.
4.96, yeah. 49.6. So because the filament and the LED both are giving us the same amount of a light, so we work out how much light is given out by the filament. So filament is giving us like 7.44 watts. And this is the same amount of a light LED is giving, which is 7.44, as I mentioned in the question. And but the input power, LED does not take 120 watt, it just takes 15 into 100. So LED is 50% efficient. So that is why you have seen nowadays that most of the light sources which we are using in our home, we are using most of them LED based rather than a filament, because filament only 6.2% efficient, but LED is 50% efficient. So only, yeah, even though 50% is not a good efficiency, but if you compare them with the filament lamp, that is much better. Like you are losing a very small proportion. And another advantage of using LED, that it can be operated by a smaller input power as compared to that of a filament. So these are the advantages of using LED over the filament lamp. The filament lamp is connected to a live and a neutral wire in the main supply. So we have a live wire and we have a neutral wire, and we connect a filament lamp or a filament bulb. The earth wire in the main supply is connected to a shiny metal shown in the figure. There is a fuse in the live wire. By accident, the live wire touches the metal. Describe what happened. Look, in the question, we have the filament is connected to a live wire. Let's say this is a live wire and a neutral wire. This is a live wire and we have a neutral wire. And the live wire is also having a fuse. And this metal is being earthed, means connected to an earthing wire. And they're saying that this live wire is touching the metal now. So what will happen? Describe what will happen.
Nothing. Nothing.
So what will happen? Now from the live wire, the current is flowing through the filament, and now the current will start to flow through the metal, and from metal it will move to the earthing wire. So as a result, the current in the live wire will increase. If the current in the live wire will increase, because of this high current, what might happen? The fuse will melt. So how to score the mark here? First thing you will mention that if a live wire is in contact with the metal, the current will flow from the live wire to the earthing wire. Then because of this, the current in the circuit live wire will increase, which will produce a greater heating effect or melt the fuse. Is it clear, this one?
Yes, sir.
Yes, I will repeat. Look, we have a filament lamp which is having a live wire connected to a neutral wire. So it is working efficiently, and there's a fuse. So the current moving from live wire going into the filament, and then this is a complete circuit. But now what they are saying, and this a metal is connected to earthing wire. So they are saying a live wire is now a bit in contact with the metal surface as well. So current is flowing through the filament and the current is flowing through the metal. So as a result, the total current in the live wire will increase. If the current in the live wire will increase, this current will produce a greater heating effect and it will melt the fuse. So as the fuse will melt or break down, then the circuit will stop or the filament will stop working. Why the current increases? Because first the current was going only into a filament lamp, but now the current is going into a filament lamp as well as the metal. So the total current will increase. Another similar lamp fuse is wrongly connected to earth wire. Explain why a person is not protected when the live wire touches the shiny metal surface. So what he did, another similar lamp is there, but the fuse is wrongly connected to the earth wire. So we have a live wire is there. We have a neutral wire. And now what has happened? A student is connected fuse to the earthing wire. So why a person, if he touch, he will get an electric shock. When the fuse will melt, so the circuit will stop. Yes, when the fuse melt in the live wire, the circuit will stop working. So what will happen in this scenario? So in this, and again, the live wire is in contact. So what will happen if a person touch, the current is moving through the from live wire to the earthing wire. Current is also flowing from a earthing wire, from a metal to the person. That is why this is causing an electric shock. Because the current always flow through a least resistive part. So as a result, the metal, when we touch a metal, the thing is that the fuse should always be connected on the live wire, not on the earthing or a neutral wire. Like even if I connect a fuse here, that is not effective. The fuse is always connected on the live wire. So when a person touch the metal, the current, electric current or the charges will flow through a body because of low resistance. So connecting a fuse in a live wire is the only option. If we connect a fuse in earthing or we connect a fuse in a neutral, it will not protect a person from getting an electric shock. Then we have question 9 and 10 and 11. 3 are there. So 9, 10, 11 we'll discuss in the next session.